Hey,
What's up?
what's up? What's up? I'm okay.
Are you ready to kick the cat's ass?
I think so. I think so. Um, I am. I've been like really, really, really like, not trying to go too hard today. So like study like, I don't know, 3, 4 hours, like did flashcards, just did like watch some videos of metabolism, just, you know, and I went over for like five, just looked at like the wrong answer or like correct and wrong answers. But
Mhm.
yeah, like trying to keep the mindset, fine. Obviously didn't do problems, but yeah, it's time, I'm so ready though to like get it all done.
Yeah.
Yeah, 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 yeah. All right, so how do you want to do this? You want to like go down the list, or how are you, like what idea do you have in mind?
Yeah. So, okay, let's try this.
Okay. Okay, so dB equals 10 log I over 10 to the 10 e negative 12.
Okay.
Loudness. Okay, substitute the dB, 110 dB. 10 log. Okay, meter away. Oh, two trombones from 1 meter away. Okay, okay. Um, okay. I mean, like by process of um, I mean, it wouldn't be D. I know that, but oh, yeah. All I remember is that equation that I just mentioned. Um. Now, two trombones from 1 meter away. I know it increases by 1 dB is like to the 10th. Um, so yeah, I'm not sure.
So, what are some things that we could do?
Um, I mean, as I said, I would eliminate these. So like, apart from that, I mean, 1 meter away. Uh, yeah, I don't really know any other equations that include sound. I mean, include like distance. I mean, like I know intensity is proportional to 1/r, like squared. Um, but or like yeah, I think. But
So what is this asking us about?
the loudness.
Well, yeah,
Well, two trombones.
compared to.
One.
Okay. So does it even matter if it's 1 meter away? I mean, considering that they're both 1 meter away, right?
Okay. So, yeah.
Okay. So you're just going from one sound to two.
hmm
So so you said the only formula that came to mind was what?
That like dBs are equal to 10 log of um I over 10 to the negative 12 power.
This?
Yeah.
Okay. And like yeah, if 110 decibels, is for one trombone with a an intensity, let's call it intensity one.
Mhm.
And then if if we have two trombones making, you know, would have yeah, so if one trombone produces some type of intensity, two trombones should have what do you think would happen to the intensity?
Like it would probably increase
By how much do you think?
like double.
Okay. So then I2 we could say is two times I1, oops, I1, right?
hmm
Okay. So with this decibel equation, we could what can we do here?
I mean, we could like maybe plug it into like I,
Okay. Plug what into I?
2I1 or 2I like initial.
Okay. And what else do we do?
Um, uh, I don't really know.
Okay.
I
So
mean, we could like multiply 2 by 110. Actually, no, yeah, we can't do that. I don't really know.
so let's see, right? Uh if we have um the decibel value, and we know the I naught value, we could solve for the intensity that way, right? Right? Like if we plugged in 110 for this, 10 to the negative 12 here, we would be able to solve for I, right?
Yeah,
And I would be the intensity of 110 decibels or loudness with so sorry. The So yeah, knowing the loudness in decibels, knowing the threshold intensity can help us find the actual intensity, right?
yeah. I mean, if we just plug in like 110, we could get I and then multiply it by 2 and then plug it back in reverse to get the dB.
Tell me what you said.
Like we can just plug in 110 here, get I, and then multiply I by 2, and then plug in I and get the dB.
Yep, you could do that. And alternatively, since I naught will be the same in, both of these intensities, like one trombone, two trombones, it could cancel out. So what you could get is this, right?
Probably. Yeah, yeah, maybe.
So if you did the math the way that you did it, you would have gotten like, yeah, we could even do it. So 110 divided by 10 is, so 11 is equal to log of I over I naught. And how do we get rid of this log?
Like just do 10 to the 11th power.
10 to the 11th power is equal to I over I naught, right?
Yeah.
And then I naught is 10 to the negative 12. So it would be 10 to the negative 12 times 10 to the positive 11, which would just give us 10 to the negative 1, right?
Mhm.
And that's your intensity 1. And so intensity 2 would have to be like 2 times 10 to the negative 1, right?
Mhm.
And we can plug that into the decibel equation to get uh, 10 times log of 2e negative 1 over 1e negative 12. That will give me 2e 11. And I would have to take the log of that over here. But yes, it's a lot more simpler to do it like this
Mhm.
because your I1 values cancel.
Mhm.
So that this would then be 10 times the log of 2. What can that be?
Uh, I don't really know. I mean, what is like the power of 10 equals 2, I guess?
Um, what was that?
Like, what's the power of 10 equals 2?
The power of, are you saying like 10 to the power of something is 2?
I
Like
mean, that's how we would solve that, no?
sure, sure, sure. Um, but you should be able to have some type of idea of what log 2 is, like what number it is.
Oh, I don't really have that idea.
Well, think about it. You could do it.
Uh,
So why don't we do this?
it's like 10 to negative like some number. Negative like can't be negative one. That'll be 0.1. Um, but probably like -2 or I don't know. My brain is like a little fried too, so like I don't really want to push it too hard, but um I mean alternatively, can't you just do you can make 10 like log. You could turn 10 into like log of 100 and then do log of 100 times log 2 maybe.
So yeah, we don't want to like whatever make it so that you get like ultra fatigued and stuff the day before your test, but we do want you to be thinking in as simple a way as possible. So if we do not know something like log of 2, what we should do is take what we do know, produce a range. It should fall in that range.
Hmm.
So
Okay.
what are some logs that you do know?
So I know the log of 10 is 1. Um I know the log of 1 is 0.
Okay.
So I mean yeah, I mean here it might be like 0 point something.
Okay. Yeah.
Um
It can be anywhere. Like, so if you're doing the log of something between 1 and 10, your answer will be something between 0 and 1, right? Right?
yeah, yeah, yeah.
Okay. So now I used to have students like memorize things like the log values just because they also equate to cosine and sine values, like, and our brain makes associations, but I largely uh don't do that anymore because it's more simpler for people to be able to just say that this range here like is roughly like 0.5.
Got it. Okay.
But okay, now what's this gonna be like?
So I mean it's gonna be like 5, I guess.
All right.
And um like I guess we would add that to like 110.
Okay.
It's my like guess.
Okay. So what would our answer here be for 12?
A.
A, right? Because like yeah, log of 2 is technically zero point 0.3. Um, of course we're rounding to like whatever zero point 0.5. But yeah, this should be kind of interesting to you in that if you so here I'll do like a takeaway here. So if you if intensity is 10 times, right? What you do then is you add 10 decibels. Okay.
Mhm.
And what if the intensity was 100 times?
But you would add up like 10 decibels.
Uh-huh. To the 10 that you've added before. So you'd ultimately have add 20, right?
Oh, yeah.
Mhm.
Yeah, yeah.
All right. Now, All right, I put another one in.
Um, okay. My guess is that it's C. Well, wait, I mean, A.
Tell me your reasoning.
'Cause 80 is 20 decibels lower.
Okay.
So, I would think you multiply 5 like times 2 and then times 2 again. That's all I could think of.
Tell me that again. You said so. Sorry, tell me that again.
That 10 decibels is like 20 decibels greater than 80. And
Where are you getting that 10 from?
I mean it's 20 decibels greater.
Between 80 and 100.
Yeah.
All right, and then what?
So I mean, because it's 20 decibels greater, um, like all I could think of is maybe it's like 5 times 2 and times 2 again. But I don't really know how to do it.
Said 5 times 2 times 2.
Yeah, so that would be 20.
Why do that though?
That's like my guess.
Huh?
But like apart from that, I don't know, I guess here we could like maybe find the intensity again and all that stuff.
That might have something to do with it.
Yeah. Okay, well the intensity is 10 to the negative second power. Um,
Okay.
and then so the intensity is 10 to the negative second power for 100 for 5 M. 10 to the negative 10 to the negative second is for 5 meters. And then um so yeah, we could also like find the intensity for 80 dBs and um that would be I mean that would be tougher because doing 8 times 10 to the negative 12. But it's like it might be like the intensity is proportional to 1 over r squared thing. But yeah, because the intensity for 100 dBs is 10 to the negative 12, and then We find it for 80.
The 10 to the minus 12 is just the threshold frequency. I mean, sorry, the threshold intensity.
Yeah, the intensity is 10 to negative second. I mean, 10 to minus 2.
Okay.
Um, but for when it's 80 dBs, it's a little tougher because it's like 8 instead of on like a log 10 scale. So it's like the intensity is 8 times 10 to negative 12. Um,
So if we have, if your intensity is 10 times larger, that would be how many decibels that have changed?
the intensity is what?
If your intensity is 10 times,
I guess it changed to like 1 dB.
so kinda, but like so you have the right idea in terms of logs. Like for instance, like let's say you change like you do 10 times the amount of like a hydronium ion, right? You'll have an increase in 1 pH unit.
Mhm.
But the decibel equation has a 10 in front of it, so it'll be exactly what would be the case for like, hydronium, but you multiply it by 10. So for going from 80 to 100 or 100 to 80, and that's 20 decibels, right? We would need our change in intensity should be by 100 times as much, right?
I mean, I guess I don't really fully get it though.
Hmm.
Like,
Yeah, hold on. Some of my pen. Okay, I'm back. So if we had 80 or rather 100 decibels turning into 80 decibels, that means that we are reducing the intensity. So let's say this is whatever, intensity one. We're reducing it by a factor of 100, right? And if we are increasing intensity by 100, and intensity is inversely proportional to the square of, that length, right? What would that R value be?
like, I don't know, like 100 over R squared.
Yeah. So if we're getting a intensity that is uh, either increasing by 100 times or decreasing by 100 times, right? We would get what would we get for R here?
What do you mean?
Um, if we are increasing that distance by 10 times, we're gonna have a decrease by it should be 100 here. But but yeah. All in all, just know that like how to deal with the decibel equation and how to relate the decibel amount to intensity and then I guess the like oops the things that can help that you can like memorize that can help you is the stuff that I wrote here, right? Meaning like, if your intensity is 10 times as much, to increase in 10 decibels and the log values and all that. But okay. So that can just be the sound thing. Because yeah, I'm just going off the list that you sent me. Um, so now let me or maybe, I guess we can like mostly like talk about it rather than like straight up doing these problems. So why don't you tell me what happens at the ETC with cytochrome C, coenzyme Q, etc.?
Oh, well, this I did just watch a video for, but like for that, it's transporter one NADH comes and donates electrons, and that powers the transporter to have hydrogens go through, and then transporter two succinate dehydrogenase. There's no hydrogens that go through, but the electrons still get attached or whatever. Coenzyme Q picks up electrons from transporters one and two, succinate dehydrogenase and succinate dehydrogenase. Uh, and then coenzyme Q gives the electrons to transporter three, which is cytochrome C reductase, and the electrons that whatever like that powers hydrogens to go through, and then um I think coenzyme Q or cytochrome C takes electrons from like cytochrome reductase, and then it gives electrons to the fourth like cytochrome C oxidase, and then protons go through, and then oxygen accepts electrons, and oxygen creates water, and then there's the gradient that was created, and then the protons go through the through the ATP synthase and make ATP.
All right. So what type of enzyme is cytochrome C?
Oxoreductase.
Okay. And there's a complex one, two, three, four. There's a complex that deals specifically with a TCA intermediate.
Well, complex two.
All right. Cool, cool, cool. So seems like you mostly understand that.
Yeah, the rest is worse.
Okay. So tell me about menstruation.
Okay, well, so basically there's the follicular phase, ovulation, and then the luteal phase. So mainly like two different phases, ovulations in the middle. I know that at the beginning there's there's like the FSH, LH, estrogen, and progesterone,
Okay.
and I don't fully remember. I know the main points. I don't remember like how each of them slowly rise. I know LH, it peaks at the end of follicular, and that leads to ovulation. I know progesterone protects the endometrium. Estrogen establishes the endometrium. Uh,
So you said for the follicular phase, I guess days 1 through 14,
Yeah.
what happens here?
Uh, so like I know LH slowly rises.
Okay.
Um, FSH maybe slowly rises.
Yeah, because it's called the follicular phase for a reason, right?
Yeah.
And the FSH is follicle stimulating hormone, so we can see, you know, a rise in FSH, right?
Yeah.
And then you can have a rise in what was the other thing you said?
Luteinizing hormone.
Uh-huh. Now you're gonna have the estrogen rise, which then causes the LH surge as well.
Mhm. But wait, but don't they like inhibit each other?
Um, maybe at a well, I'll have to look into that, but uh yeah, I'll look into that. Um, but yeah, this is what is happening in that follicular phase. And then on day 14, you have ovulation, which is when the egg is released. Oh, and it's right before, so over here, LH surge, right?
Hmm.
Okay. And that causes the release of the egg. And then we have our luteal phase, days 15 to 28. And what's happening here?
Uh, so here, if I mean, if there is a if there's like a sperm cell, I guess it like fertilizes
Okay.
the corpus luteum, or no, like I guess like the egg leaves the corpus luteum or whatever.
Okay. So you could say let's say with fertilization, without fertilization. So if you have fertilization, um, that luteal phase is going to create well, that corpus luteum that was created from like the follicular phase, or sorry, after the follicular phase, during the luteal phase, the corpus luteum forms. Um, so right, corpus luteum causes progesterone, and this ultimately prepares the endometrium of the, you know, uterus to like thicken and start to have a lot of blood vessels. Um, and basically gets the uterus ready for implantation by that fertilized egg.
Hmm.
And that's what's going to happen if if there's fertilization. But if there isn't any fertilization, your corpus luteum uh degenerates, and you should also have a drop in progesterone and estrogen.
Hmm.
And here is a picture of exactly this phenomenon here. And you see how they all line up here. This one might be even better. Oh, never mind. Uh, yeah, so that's the thing for yeah, so that's essentially that for um menstruation.
Hmm.
And you were oh, sorry, you were saying something about something inhibiting something?
Like, I mean, I was just saying that estrogen and progesterone, they like inhibit LH and FSH or something.
Mhm. Yeah, so
Yeah.
it could cause negative feedback, uh, unless it's like whatever. I think estrogen reaches its surpasses its threshold. But yeah, you like I think ultimately the way to view it would be that for that follicular phase, you are having an increase in your estrogen as well as your follicle stimulating hormone, but the spike in estrogen or that rise in estrogen can cause the luteinizing hormone to spike, and that triggers ovulation and the luteal phase, and that's all about, in the case of fertilization, making that endometrium very, very full of blood vessels and all this stuff. But if it's not, then it's just like menses, uh, which is just like the blood kind of coming out. So that's some stuff with menstruation. Now, harmonics. Tell me about that.
Harmonics, I know just the main stuff is like open is 2L over N. And then the other two are closed. Well, closed and open are 2L over N. And then closed open is 4L over N. And then I know that for closed open or whatever, like open closed,
Tell me what you're saying first. You're saying something what
the length is like 4L over N or the wavelength.
okay. So I think it would be the easiest to think about it in terms of the formula for the frequency.
Okay.
Like like that.
Uh-huh.
That too. So
Yeah.
the even ones are going to be the formula on the left with the 2L on the bottom, and the odd ones will be the one on the right with the 4L on the bottom. Now, uh, so okay, so the fundamental so we have different n values, right? So our
Yeah.
fundamental frequency is when n is equal to what?
N is equal to 1.
Good. And that's going to be the largest frequency, right?
Yeah.
So, um, so wait, no, I'm wrong. And that should be the smallest frequency because the later frequencies would be
Well, it's gonna be the okay, it's gonna be the biggest wavelength, right?
yeah.
Okay.
So now okay, so for these when they are when okay n is equal to 1, both of these will be describing the fundamental, which could also be called the uh well, it'll just be called fundamental, but if this is now n is equal to 2, this would be called the first overtone as well as the second harmonic. And for the odd one, n can only be odd numbers like 1, 3, 5. So the odd one is not going to have a second harmonic because the next one is going to be n is equal to 3, which is the third harmonic. But it will still be the first overtone. Okay.
Mhm.
So that's the deal with yeah, these harmonics. And like a shortcut is like, let's say, since like, F, the fundamental frequency is when n is equal to 1. That means if n is equal to 2, you could just take that fundamental frequency and multiply it by 2. So for instance, like the set of frequency 2 is just could just be 2 times frequency 1 or the fundamental, right?
Mhm.
Okay. So that's some harmonic stuff. And changing mediums, you're going to have a change in velocity, which could cause a change in wavelength. You're not going to have a change in frequency. Um, but let me see about the amplitude. Okay, so the amplitude of a wave seems to be the intensity of it, and that this can either, like when you're going from one medium to another, can either decrease it, sorry, the amplitude can either decrease or remain the same, but it cannot increase,
Mhm.
right? So got it. Okay. So now let's see the other thing. Oops. Microtubules, microfilaments, intermediate filaments. What are your thoughts on that?
So I know microtubules, or no, microfilaments, that's actin, myosin. I mean, I know actin is a microfilament, and then myosin is what acts on actin.
Okay.
That's like the main thing for microfilaments. I also know cleavage furrow is microfilament, I'm pretty sure. Like it's just associated with that. Um, so microtubules mainly, I think of dynein and kinesin, but from what I remember, like they are like on the microtubule or something along those lines. Yeah. And so they're like motor proteins, and then I know dynein like carries stuff toward the nucleus, and kinesin carries it away. So retrograde is dynein, anterograde is kinesin. Um, so wait, so yeah. Um, microfilaments is that's actin is a microfilament, right? Intermediate filaments, I don't know as much. I mean, and it's like cytoskeleton. De desmosomes, is that a
Mm-hmm. Uh-huh.
yeah. Wait, they anchor intermediate filaments. Okay.
check out this video that I'm putting in the, what's this thing? Oh, or actually I can share it. So can you see what,
Yeah.
yep. What do you,
Okay.
yeah.
So yeah, there's just like a bunch of air.
Sorry, say that again.
There's like a bunch of air all at once.
So what you're having here, you said about air.
Yeah.
Can you see this GIF that I put in?
Yeah, I can. Well, it's not like moving. That's the thing.
Oh, see if you can click on it, like, or rather double click on it.
Yeah, okay, it works now.
Yep. So, so this is, so you can see how this can cause like a Doppler effect in like how the sound waves coming from the source here are getting bunched up in the front because it's moving in that same direction.
Hmm.
Now, what's happening in addition to that, though, is it's starting to move faster than the sound,
Uh-huh.
right? And that's why in the video that I just showed you, you saw the plane pass, but you heard the plane after it's already passed.
Yeah,
That's, and the sound, that loud sound that you heard is the sonic boom.
gotcha.
So, uh, have you ever heard of the A10 Warthog?
No, I haven't.
Well, it's a jet that I mean, that we have that shoots depleted uranium. And the sound, they call it that the Warthog because it has this very distinct kind of like Warthog-like sound. And the reason it has that type of sound is you hear the bullets landing at their target before you hear the sound of the bullets leaving the gun.
Hmm.
So that's another thing that's so essentially if you are moving faster than the speed of sound, which is like 330 meters per second, right? You're going to have a sonic boom,
Got it.
right? So, because yeah, you mentioned that in the email.
Hmm.
And then we have okay, calcitonin versus vitamin D.
Yeah.
Yeah, what are your
So I know calcitonin like brings down amount of calcium, and uh basically like it brings down the amount of calcium in the blood, and that leads to bones being built, and like osteoblasts do that. And then PTH is like the opposite of calcitonin, where osteoclasts break down bone, so that's called mineralization.
Mhm.
And so I kind of know, I guess, differences between calcitonin and PTH, the general ones, but with vitamin D, I know it's a steroid hormone. Like, right? Is Okay, it's a steroid hormone, and what I want to confirm, does it like do the same thing as PTH? Like, what are the differences? Because I know, or does it do what calcitonin does? Like,
uh yeah. Calcitriol is vitamin D, and parathyroid hormone is also involved in the regulation of calcium. Um, and yeah, they work in opposite ways. Like parathyroid hormone is going to raise blood calcium, which means it's gonna start to like demineralize bone to take the to take the calcium from the bone and put it in the blood. That's what the parathyroid hormone does, right? And your calcitriol, which is vitamin D, is going to help take the blood calcium and incorporate them into the bone, right? And then calcitonin is going to, which is another thyroid hormone, is going to work in the opposite direction uh, of the calcitriol of the vitamin D. So calcitonin is going to lower the blood calcium and having more, of the osteoblasts take in the calcium.
mhm. Wait, so this PTH it leads to um like what does PTH do?
Oh, it lowers the amount of calcium like in like the bones to make so that there's a higher amount of calcium in the blood.
Okay.
Um, yeah, so you should know like, that in addition to like if they're stimulating osteoblasts means that they're building the bone. If they're stimulating osteoclasts, it means they're breaking down the bone,
Mhm.
right? So
Yeah.
let me like that can help is like calcitone it, like tone it down, less blood, uh, you know, and yeah, so all in all, calcitonin is going to lower blood calcium and cause there to be, a higher amount in the bones, and the vitamin D acts just like the calcitonin, um, meaning, it's going to. Oh crap! Hold on.
No, yeah, I'm pretty sure it's the opposite.
I'm wrong. I'm wrong. Okay, let me fix this. I'm just gonna write it here. Calcitonin is tone it uh down. So like low blood calcium. Parathyroid hormone is going to be increasing blood calcium. And what was the vitamin D? And that's going to increase the blood calcium.
Mhm.
Okay, it's that. Then let's see. You said my beta oxidation fatty acid synthesis. Um, I'll go that over that last. Let's see. Sonic boom. Okay, conservative versus non-conservative forces. What's your understanding of that?
So I know that conservative forces, it's I think like gravity,
Yeah.
and then non-conservative is something like friction, where heat is lost.
Uh-huh. Yeah. So you will indeed have like if you yeah like something like friction, right, or air resistance or whatever. Energy lost to the environment as heat, and that's good for non-conservative. Um, and I guess one other thing is if something is path dependent or not. So right
Okay.
about that. So um conservative versus non-conservative. So some examples of conservative could be like electric force, gravitational force, uh, I guess like elastic or force. Because yeah, the path does not matter when it comes to that. Um, but the non-conservative forces, in addition to losing energy in the form of heat, is indeed going to be path dependent.
Mhm.
That could include friction, well, I guess I should say force of friction, applied force, tension, could be things like that as well. So,
So gravity, force of electrostatic force.
mhm.
Okay.
uh, yeah, because like, I mean, okay, let's say that you're going from point A to point B and you go in this type of path, whereas here, something like this, you're the one on the right is a longer path from A to B, even though the distance between A to B are the same. And
Uh-huh.
that's going to be like the force of friction, because let's say that this route from A to B on the right is like the path that you must take. And if you have friction there, this like longer path compared to the straight line path, the longer path is going to produce more friction, right?
Yes.
So that's another aspect. Whereas for like A and B, like the gravitational force between A, oh, it keeps messing up my.
So non-conservative forces are path dependent.
Correct.
Mhm.
Okay. So, yeah. So like for instance, like a gravitational force, like it's gonna be like mass one here, mass two, and r is the distance, like the straight line distance between the two. It doesn't really matter if this like the gravitational force goes like in, some ridiculous path like this. It's
Right.
still going to be the straight line distance between the two. So the gravitational force, if you take this path going straight, or if you take this like really crazy path, you're ultimately going to have the same amount of gravitational force, right? But, yeah, if there was friction, this increased distance is gonna play a role.
How about state functions and like process functions?
Um, that's a good question. Like versus path function, I think you're thinking of. I think
Yeah.
yeah, that's actually the same thing. Uh, but I guess conservative forces are going to, let's say that this means both a state function as well as energy being conserved, whereas the non-conservative is going to be a path function, which means it depends on the path, as well as yeah, energy is not conserved and therefore released into the environment.
So force applied is is that what you wrote? On
Oh,
the force of friction?
yeah, I wrote friction as well as the force applied.
And what exactly is the force applied?
Oh, that's like usually the example I give is like some dude is pushing against some box with some force, right?
And that would, I mean, how about normal force? That's what, like in terms of conservative, non-conservative.
Um, like I get if you let's see, because okay, if I had a box here, this is the force of gravity, this is the normal force. Now, okay, now what if I had an inclined plane? Yeah, it would have to be non-conservative. I was gonna say in in the case of friction, it's non-conservative because the normal force is what contributes to the friction. But I wonder if it were like it requires that or not. Let me see.
It's we can move on to the next topic.
Yeah, sure.
I don't want to take too long on
Yeah, yeah,
each
no.
of these.
So,
So isobaric, isovolumetric, that stuff.
mhm.
And I guess we could tie that in with like PV work and UQW.
Okay.
But I mean, I know isobaric is the same pressure.
Mhm.
Isovolumetric is the same volume. There's adiabatic, which is no heat, and then I think there's a fourth one, but I'm not sure.
So let's see. All right, I threw a question in there.
Okay. I'm not really sure. I would maybe pick B.
Well, you chose right.
But it's like a guess. I mean, yeah, I don't really know. I don't know this that well, but like
Yep.
maybe because
Yep.
there's no collisions happening. Like the collisions are irrelevant.
So uh, uh, gas particles have the same average kinetic energy before and after because
Yeah,
they have the same temperature, right?
yeah.
And the um oh yeah, the internal energy is like that delta U that's equal to the Q my the heat energy Q minus W work. And
Hmm.
so if you have conservation of energy, then the delta here, I'll write it. The delta U equals Q minus W. And if this is going to, so if you have energy being conserved here, that means that the heat energy, Q, should be equal to the work done, W. And by the way, the work could be PV work here if we're talking about gases.
Hmm.
So kind of connecting it to the what you wrote. And
Right.
now, yeah, in order for the energy to be conserved, we would have a delta U, which stands for that internal energy, to be zero, so that the Q can be equal to the W, or the equal to the P delta V, right?
Yeah.
So that means that your internal energy should not be increasing, right? It should be zero.
Hmm. Well, is the internal energy like delta H?
Well, delta H is like your enthalpy, and that could be a little bit closer to like the Q because that's like the heat flow, but like yeah, they're gonna be kind of different, yeah.
Mhm.
And for
I'll be
the
right back.
yep.
More practice problems. Okay. The top one is C, I think.
Um, so you're saying does not move?
Yeah.
So uh okay, so what's happening here is so continuity equation.
Yeah.
Um and that would be like the inverse proportion between velocity and area.
Hmm.
So like here compared to like here, right? Like let's say this is like area for A and this is area for D.
Yeah.
Uh so okay, area A is smaller than area B. Now,
Hmm.
what does that mean for the velocity at these points?
Like the one where the area is smaller, the velocity is higher. So on the left.
Good. So now when we consider this like whatever canal between um like yeah, like that opening and this opening here. Well, first of all, we also need to remember that so I guess so I said the continuity equation, but that's kind of like a consequence of Bernoulli's equation ultimately.
Mhm.
And Bernoulli's equation looks like this, right?
Yeah, yeah.
And so we could see some relationship between, I mean, like they're the same height, so let's get rid of this. And then we can see an inverse relationship between pressure and velocity.
Mhm.
So, like, so let's say this is pressure at A, pressure at B. Compare, like, the sizes.
I mean, on the left, like if it has a higher velocity, then the pressure is going to be lower.
Yep. So you could say pressure of A is less than pressure of B.
Hmm.
Okay. So here, there's a higher pressure here than here, right?
Sure, but I could say the velocity is higher on the left side, so it's pushing water in, no?
Well, the velocity on the left side is going to like, the right side like that, right? The only way that this would go into like the canal system here is if there is a higher pressure there. It's this is just a less exaggerated version of, the types of problems where we had like some manometer attached to like a Venturi meter, like something like that, where like let's say the water level for the manometer is higher here on the right compared to the left. Like let me call this A, let me call this B. The pressure at A and the pressure at B, which would be larger, which would be smaller.
Well, the pressure at A would be larger.
Yeah, right. It's, pushing it down inwards. So
Yeah,
this example is the same thing, it's just less exaggerated and it doesn't have a different liquid inside, but same principle should apply.
gotcha.
So what do you think that would be then?
Well, I mean, if there's a higher pressure, it would move, I guess, from the right to the left.
Yep, good. Okay. And then let's think about this one here. Because I feel like 100% there will be a question like this.
For
Something
real? They told you?
they told me, but I don't think they'd ever tell me any,
Uh,
you know. Uh,
why not? You should have asked them.
it's funny. I was thinking of asking Altius for like a discount code or something because I
You
send
should.
students, but and I was also gonna ask like, well, like um, so, like one of my students who's taking the test like is spreading it like he has an accommodation so he could take it like over 2 days.
Hmm.
So I'm seeing him tomorrow after like the first two sections, and
Hmm.
like I hope he has some good like knowledge like info about
Right.
what they're testing. Because oh, another thing I wanted to say was I don't like it's been super long, so I don't remember, but I don't know if the passages on the MCAT they have that citation on the bottom.
Ah, okay.
Yeah, and yeah, I wanted to say mention that to you because I noticed that you like kind of highlight down there. It can be wrong, of course, but
That's good to know. I mean, I if they don't have it, like I'll know after the first passage. So,
yeah. So,
but yeah, okay. Well, we'll look here. So the weight of a sample of mineral ore was measured using a spring scale and found to be equal 12 newtons suspended in air. Suspended in water, the okay, okay. This is easy.
mhm.
The way to get this is you do 10.5 over so I'm pretty sure it's weight over air minus weight in water. So 12 over 12 minus 10.5. 12 divided by 1.5. 12 divided by 1.5. 1.5 is 5 over 2. Wait, yeah, 5 over 2. 12 divided by 5 over
Uh,
2.
you're saying 1.5? 3,
1.5 is 5 over 2.
3 over 2?
3 over 2.
Hmm.
Okay. 12 divided by 3.2, so that's 12 times 2 over 3.
Yep.
And then answer, wait, so D? I mean C.
Yep. Yep. Yep.
Okay.
Awesome. All right. So let's see. We covered a lot of this stuff, and I said I was going to do beta, yeah, beta oxidation last. Ooh,
Cool.
yep.
How about the Nernst equations and Malate-Aspartate shuttle? Is that like very I
Oh,
won't say low yield, but like
oh no, yeah,
you
yeah.
don't
Yeah, I forgot. Okay, so the Nernst equation can help us find. Okay, let's see. So these value, like the two forms that you wrote, like with the RT over NF, and then the point.
wait, quick question.
Yep.
Uh buoyant force is density of fluid times velocity of object that's displaced times G.
Buoyant force is rho or density of the fluid that's getting displaced, the volume of the fluid that's displaced, and little g.
Okay. That's all I want to ask. All right, what are you asking?
Um, oh yeah, so both of the here, let me copy and paste this. Yeah, so the Nernst equation, like the one with the negative or the RT over NF, like oops, like this is just simplified to the 0.06.
Yeah, I know that part. I'm just wondering when will I have to use it?
Um, okay, I guess that's a good question. So since we, okay, let's see. Since we could relate Gibbs free energy to cell potential, and we could also equate it to um
Negative RT ln KQ.
yeah, yeah,
Um,
yeah.
and then yeah.
Yeah. So okay. So our standard compared to our new situation, I guess. The standard is going to involve the K rather than the Q. So, okay, so this is this plus this. And now if I, okay, then this should have to be Q. Divide both sides by NF. We get cell potential plus the RT over NF, ln of Q. And Yeah, I guess that would then be the this wait, this is the I'll put a circle there for the standard and that. Well, I guess I just derived it, but to answer your question about when do we use this, I guess if they asked or like okay, let's see. So I feel like either they will give you a let me just type in this to MCAT. Yeah, so I think this is something that they could ask you if they let's see, expect you to make a comparison between like let's see. Yeah, so I think that so this is just so you would use so the circle like degree symbol on top of the delta G and on top of the E cell is under standard conditions. And so the Nernst equation is to figure out your cell potential under the non-standard conditions.
Oh, okay.
And that's also why you have a reaction quotient, Q, rather than K.
Hmm.
And also, like, you're doing so in this form, um, here, like I noticed the ln turns into log. So I
Yeah,
think
yeah.
got the E Euler's number, like they got rid of it or something.
Got it.
But yeah, that's what you would use for that. Um, and I mean, it's usually not one that I see often, so I feel like if they did ask you about it, like they would give it to you. Uh,
Hmm.
then let's see, the malate-aspartate shuttle. Um, okay. So I guess if we think about so NADH is not going to be something that can cross the mitochondrial inner membrane, but you need it for, the electron transport chain, right? So the malate aspartate shuttle can move the electrons into the matrix without having to move NADH instead. So for instance, it can take a malate and oxidize that into oxaloacetate, which requires NAD plus to turn into NADH.
Hmm.
And that's a way that you can essentially get that NADH, even though it's not like, the identical same molecule, but like you can still get your NADH into the mitochondrial matrix.
Hmm.
So like let's say we have like um let's see, whoops. something like this. You could have so like yeah, let's say that we want um to bring cytoplasmic NADH to donate electrons to oxaloacetate. We can have the malate enter in to the mitochondrial, matrix via the whatever, the malate shuttle, and it can then interact with NAD plus to create oxaloacetate and NADH. So that's a way for us to get that, like, to get an NADH to be inside of the matrix. And then, giving its protons away to like complex one and stuff. Um, and I believe that the malate shuttle predominantly involves entering into the mitochondrial matrix, whereas I think as the aspartate channel or whatever shuttle will help oxaloacetate go back to the cytoplasm.
Okay. Let's just do beta oxidation fatty acid
Oh yeah.
synthesis.
Yep. So I have a like PDF for that. Let me get it. Is this legible? For some reason, for me, I can barely see it. Like
Well, I mean, I can see it, I guess, yeah.
here. You can see it?
Yeah, I can see it. You can't? Like maybe I could download PDF and share it my screen.
So, okay, so let's go by what you can see. So, uh, yeah, what am I writing here up top?
Fatty acid oxidation
Huh?
shows a triglycerol. Fats can be metabolized only aerobically.
Mm-hmm.
Fatty acids are degraded 2C at a time via dialytic cleavage.
Yep. So we have our triglyceride drawing here. Step one, you have lipase. We're adding three waters, and we hydrolyze the glycerol from the three fatty acids,
Hmm.
and the glycerol can enter into Krebs by turning into whatever, like DHAP and pyruvate, and then ultimately into acetyl-CoA, which is what everything converges to. And that
Hmm.
acetyl-CoA could be used in the Krebs cycle and the ETC to make ATP. Um, there's an activation step that takes place on the outer mitochondrial membrane, and and it uses 2 ATP to like activate that fatty acid. Um, Meaning, to have CoA attached to it. And then it gets shuttled in by carnitine to bring that acetyl-CoA in. And once we have that acetyl-CoA in, the mitochondrial matrix, we begin a beta oxidation. And you can see some of these um, steps here where we have, wait, yeah, so you could see that um, I also wrote. So do you see where I wrote like creation of one FADH2
Hmm.
and one NADH plus H plus each time yields like a shit ton of ATP,
Right.
Krebs and ETC and all of that stuff. Um, and yeah, it cleaves 2 carbons at a time, with meaning that those 2 carbon molecules can turn into acetyl-CoA. Um, and then I have an example of doing beta oxidation for palmitic acid, which is an even numbered fatty acid. And you can see what I wrote for that, right?
Yeah.
Okay. So, so up here you see that I wrote the entire like whatever fatty acid, and I'm like cutting every two like CH2 bonds to ultimately get 8 2-carbon fragments. Now, that means I've done beta oxidation 7 times to get those 8 2-carbon fragments. Uh,
Okay.
but yeah, the fragments essentially turn into like acetyl-CoA, and so if you wanted to convert that into ATP, you would have to take into consideration like, okay, losing 2 ATPs from the activation step, gaining from each round of beta oxidation, you're gonna like of the 7 total here, 7 FADH2s, 7 NADHs, and then you should also know that like how many like an FADH2 is like around 1.5 or 2 ATP. NADH is 3 ATP, so 7 NADHs, 21 ATPs, 7 FADH2s, 14 ATPs. Then you have the acetyl-CoA that breaks down, and ultimately you get like 130 type, like whatever, ATPs, which is a huge, huge, huge amount. And then the last thing would be if you had odd numbered fatty acid, and you're still going to be like cleaving uh 2 carbons at a time to turn into acetyl-CoA, except the last like thing that you're left with will have 3 carbons, and that'll be instead of an acetyl-CoA, a propionyl-CoA.
Hmm.
Okay.
Okay. Let's try to be done by 6:30.
Yep.
Um, just because I want to make sure to eat like I've been eating at the same time. But
Yep. Yep. Yep.
okay. So propionyl CoA is that like what is the difference between propionyl CoA, succinyl CoA, and acetyl CoA?
Well, the succinyl one is more
Just
it's kind of specific.
Krebs?
Yeah, yeah. Like with succinate and things like that. But your question was, oh, the difference between acetyl and propionyl.
Yeah.
So yeah, the acetyl, we kind of touched upon that yesterday, but like it's just acetyl group is just a 2 carbon. group with a carbonyl oxygen.
Yeah, so acetyl-CoA, but I mean like I know what acetyl-CoA is, but I'm saying like compared to propionyl, like is propionyl a longer form?
Oh, yeah, just one extra carbon.
Okay.
Hmm.
All right.
Yeah, what would should be the next topic?
I mean, we went over. I think we can honestly just stop it here.
Okay,
Yeah.
got it. So let's see. Okay, so yeah, you know, basically, you're 1,000% ready. You just do what you've been doing, which you're good at being able to do. Pretty, very, very disciplined and everything. Um, and um, yeah, obviously, like fine, you've already pretty much found that balance between time and accuracy. You're able to adjust that as needed. Um, your practice scores, test scores have been super consistent, and you've, been through the ringer with all the Altius and blueprint stuff. Um, um, we haven't done much psych soc stuff, but I have a feeling that's okay, like where you're at there.
Hmm.
And I guess also, yeah, just basically do what you've been what you've been doing. Like that goes for cars, that goes for the sciences as well. And yeah, give yourself time to think. Obviously again, hard to balance that with the time crunch. Um, but but yeah, make sure you rephrase the question and make sure you understand what it's asking for. And, like, of course, read it all. If you're in a total, like, bad situation, um, you can kind of, like, just, like, let's say, like, 3 paragraphs in, like, for cars, 3 paragraphs into it, like, ask yourself, like, okay, like, do we have any repeated ideas? Um, yeah, for the math stuff, you're good. For the science stuff, you're good. Um, remember how that if you're dealing with buoyant force and you have, the buoyant force going up and the gravitational force going down, remember that the gravitational force, mg, you could turn into density of that object, volume of that object times little g. You do that.
Hmm.
Know that, uh, difference between like sine and cosine.
Yeah.
Um, like you'll see cosine in work because it's maximize at 0 degrees. You'll see sine like for torque or like magnetic force. Um, and yeah, I think you're super ready.
Yeah. At this point, like
Yep.
just like I've done, I mean, countless amounts of hours
Yep,
studying.
yep.
Like I'm not, I'm just
Yeah,
yeah, gonna take it easy with the rest of today and yeah. Whatever happens, more happens. I just know I can sleep knowing that I gave it my all. Like I
absolutely.
really did. So like
Yeah, no, absolutely. Yep.
yeah.
You've made an enormous transformation here. Um, and even like, counting like just the last 3 days or whatever, you've made tremendous improvement. So yeah, so like whatever time you normally go to bed, do you like just go to bed a little bit more early just because people have a hard time
Yeah.
the night before? Do everything that you're doing the same exact way. Uh that feeling that people have around psych soc where you're so close, you're almost done. Try to resist that and give it your all, and then
Yeah.
you're done, done, and then
Right.
yeah, you're straight up done. So yeah, I think you're gonna crush it, and it's been a pleasure. And
It's been a pleasure. I mean, we'll see in a month. I mean, I'll let you know how it went. Like, I'll let you know like my overall thoughts.
yep,
But anyway, yeah, like I'll obviously email you.
yep.
But yeah, it's definitely has been a pleasure. But like, it's not like we're, stopping communication right after this ends. But
Yep.
that would be sad. But like, yeah. Anyway,
All
thank
right.
you so much. Of
Yep.
course. I'll let you know. And how much was the total?
Oh yeah. See. Can't even. Are you are you with do you hear me?
Yeah.
Oh, I don't, yeah, I like lost the Zoom like screen or whatever, but I'm pretty sure it was like 2 hours, so I think it'll just
Yeah.
50.
Okay.
But yeah, go crush it.
Yeah, I'll make you proud. I'll make you proud.
Yeah. All right,
All
take
right. Bye.